Hi, everyone. Welcome to lesson 2.3, linear functions and slope. So this is meant to be sort of a review lesson for pre-calculus algebra. Hopefully you've learned about linear functions before, you've graphed lines before, you've learned about slope, and this is meant to be kind of a refresher of those things. So we start off seeing a definition of slope. We use the letter M for slope. And the definition of slope, you can say it in different ways. You may have heard the phrase rise over run, but we see this ratio really. The rise is the change in y, or vertical change in your line, compared with your run, or x, which is your horizontal change. And then the formula that we use to calculate that is y2 minus y1 over x2 minus x1. So I'll just jot that down, rise over run. And when I say over, I'm really writing it over as in a fraction. So a slope is generally going to be some kind of a ratio or a fraction. The fraction may or may not be something you can reduce. So in this example, we're going to find the slope of the line that passes through 2 points, 3, 6, and I'll label that x1, y1, and then 1, 2, I'll label that x2, y2. You could do it in the other order if you prefer. It doesn't really matter. Pick a point to be point number 1, pick a point to be point number 2. It'll all work out either way. So now when I start to plug in y2 minus y1, that would be 2 minus 6. And then x2 minus x1 would be 1 minus 3. 2 minus 6 is negative 4. 1 minus 3 is negative 2. Negative divided by negative is positive. And 4 divided by 2 is 2. So you might think of it as 2 over 1. And you'll notice this line that's graphed here to the right, you can see the line going actually up 4 over 2. Or now that we know the slope is positive 2, you could even see it going up 2 over 1. Up 2 over 1. So both of those slopes are correct. The most simplified version, of course, is just the 2. But again, notice it's going up from left to right, up 2 over 1, or up 4 over 2. If you're wondering about our negatives that we got, another way to see this slope would be going down 4 and to the left 2. But to me, that's much more confusing. So it's easier to see it once you reduce and see that the slope is positive, again, going up from left to right. Okay, so speaking of positive, there are 4 different types of slope. Positive is one of them. So that's this red line here going up from left to right. Slopes can also be negative. That's this blue line going down from left to right. And then beyond that, our slopes could be 0 or undefined. So this bottom left example is a horizontal line going through the y-axis at 2. The equation is y equals 2. That line has a slope of 0. I'll write that here for us. 0. So m equals 0. In other words, we're going up 0 over 1 or up 0 over 5, really up 0 over anything. So I'll just write it as 0 over 1. So it's not going up at all. In other words, there's no rise, only a run. So sort of a flat horizontal line, slope is 0. Whereas when you have this straight up and down vertical line, in that case, we would say our slope is undefined. So I'm just jotting that down, undefined. So as a fraction, you might see it as 1 over 0 or negative 5 over 0. Anything over 0 we know is undefined. So it has rise, but no run. Okay, so again, our 4 different types of slope: positive going up from left to right, negative going down from left to right, 0 is just going horizontal, side to side, and then undefined would be when it's going straight up and down as a vertical line. Okay, very good. So we're on to the next page now. This is the 3rd slide of your notes. We're now going to see some examples of equations of lines. So probably most people are more familiar with the second one you're seeing on the screen, slope-intercept form, y equals mx plus b. That's usually going to be our goal of what our final answer will be in. But you will see these questions where we start by writing an equation in point-slope form, and then we transition into slope-intercept form. So the one on the left that you're seeing is called point-slope form. This is really useful when you're given one point that's not the y-intercept, and then you're also given the slope. Remember, with slope-intercept form, y equals mx plus b, b is a very specific point. It has to be the y-intercept. It has to have that 0 as the first coordinate. So in this example down below, write the equation of a line with slope 3 that passes through 2, -5. We do not know the y-intercept. That -5 is not b. So we can't just immediately go straight into slope-intercept form. We'll start by plugging into point-slope form. So let's start by actually labeling what information we have. We have our slope of 3, that's m. We have our point 2, -5, that's going to be x1, y1. So when I start plugging into my equation here, y minus y1 will be y minus -5 equals, and then m we know is 3, parentheses, x minus x1 is now x minus 2. This is point slope form. Really, the only simplifying I'll do is changing the y minus -5 into y plus 5. And that's as far as we're going to go for that first part. You might have gone ahead already and started distributing the 3 and working on solving for y. That's going to be in our next part. So what we just did is found an equation in point slope form. So y plus 5 equals 3 parentheses x minus 2. To get to the second part of the question, to write the equation in slope-intercept form, now we get to solve for y. So let's take what we just did and start simplifying. We can distribute, get rid of parentheses, and then get the y by itself. So now I will distribute that 3. Y plus 5 equals 3x minus 6. And then we can finish by getting the y by itself, subtracting 5 on both sides, y equals 3x minus 11. That would be our final answer in slope-intercept form, y equals mx plus b. So our m, of course, is still 3, but now we can tell, oh, the y-intercept b is actually -11. So this line would cross the y-axis at -11, and the slope would be +3 or +3 over 1. So we would be going up 3 over 1 if we were to make this graph. Okay, we're going to see another example similar to this, only now we have a fraction. So we need to make sure we're comfortable plugging in fractions. Okay, so same idea. We're given a slope and a point. So write the equation of a line with slope -2. So there's m. That passes through a point, -3, -3 over 2. So that's x1, right? x1, y1. Okay, so point slope form, here we go. So y minus y1, that's y minus -3/2 equals m, that's -2, parentheses, x minus x1, so x minus -3. Okay, so lots of negatives here. The only simplifying we'll do is changing some of this expression where if you're subtracting a negative, we'll change it into addition. So instead of y minus -3/2, we'll change that to y plus 3/2 equals -2, parentheses, and then we'll also change this inner expression. Instead of x minus -3, we'll change it to x plus 3. And now we're done writing our equation in point slope form. So this is our final answer in point slope form. Y plus 3/2 equals -2, parentheses, x plus 3. Moving on to the second part, now is when we get to solve for y. So we get to distribute. So we'll distribute the -2. So that's now equals -2x minus 6. We still have the y plus 3/2 on the left side. Okay, so to finish solving for y, we do need to subtract the 3 over 2. And you can use calculators for this part, but you know what? You should be able to do it without. So let's just remember how to combine fractions when you're adding and subtracting. We need common denominators. So I'll just jot that off to the side here. When we combine -6 minus 3 over 2, -6 over 1 can be rewritten as -12 over 2 if I multiply the top and the bottom of the fraction by 2. So this becomes -12 over 2 minus 3 over 2, which now we can combine those fractions because they have the same denominator, and it becomes -15 over 2. Okay, so I'm a little bit out of space here. I'm going to clear some room and then write the final answer. So over on the left-hand side here, let's write our final answer in slope-intercept form. So y equals -2x minus 15 over 2. We just figured out that fraction part. Because when we subtracted 3 over 2, we were subtracting it from -6, and we did that by getting a common denominator. The -6 became -12 over 2, Negative 12 over 2 minus 3 over 2 became negative 15 over 2. And we can leave the answer like that. Generally, we leave it as a fraction rather than a decimal or a mixed number. So just leave it as an improper fraction for the final answer. Great. Okay, so we've reviewed some things about slope. We've reviewed equations of lines. And next, what we get to do is practice graphing using equations of lines. So what we're going to do is take these equations that we see and rewrite them in slope-intercept form, y equals mx plus b. We'll identify the slope and the y-intercept, and we'll use those two pieces of information to make our graph. The y-intercept will be our beginning point, and then the slope will tell us how we're going to rise and run from there. So here's our equation, 7x plus 9y minus 63 equals 0. So clearly this is not in slope-intercept form. Let's work on getting it there. We're going to solve for y. So I'm going to move that 7x by subtracting on both sides. At the same time, I'm going to get rid of that minus 63 by adding 63 on both sides. So kind of two things at once here. So then we get 9y equals negative 7x plus 63. 0 plus 63 is still 63. And then we can divide by 9 to finish solving for y. So I'm dividing each piece by 9 here. I'm going to rewrite the answer up top. Y equals negative 7/9 x plus 7. So 63 divided by 9 is positive 7. So now we have enough information to make our graph. So the plus 7 is the y-intercept. We can just write 7. And then the slope, that's m, right? Y equals mx plus b. The slope is the number in front of the x, negative 7/9. So that's enough to make our graph. Here's what it's going to look like. We'll start at 7 on the y-axis. Okay, try to click accurately here. So here's 7. Just making a little black dot here. And then our slope is negative 7/9. That means we're going to count down 7 over 9. So from the y-intercept, we'll count down 7. 1, 2, 3, 4, 5, 6, 7. And then we'll count over 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so our next point happens to be over here at 9, 0 on the y-axis. Okay, I'm going to cheat a little bit and use my special tool to make a straight line, but you do your best there. Connect those points. I'll extend it beyond those points here. Here we go. And then we'll add some arrows to show that we know the line continues forever. Okay, so again, we solved for y. We got our equation into slope-intercept form, y equals mx plus b. We started at the y-intercept of 7, and then we used our slope to count rise over run. Because it was negative, we counted down. If it was positive, we would have counted up. So we counted down 7 over 9 to make our next point. Okay, very good. And I think we're on our last graph now. So the last graph we're going to do, you can see the equation is much shorter. 5y minus 10 equals 0. So there's no x here, which is just something to notice. We can still solve for y to make this graph easier though. So let's solve for y. So we'll get the y by itself, add 10 to both sides. 5y equals 10, divide by 5, and we get y equals 2. Okay, so take a look at that. See if you recognize previously, did we see a line that had an equation like this, y equals a number? We did. It was back on that slide that showed the different types of slope. So this is one of the types that doesn't have a slope that's positive or negative. This actually will have a slope of 0. So if I rewrite this, instead of y equals 2, you could write it as y equals 0x plus 2. That's not fully simplified. Y equals 2 is still the best answer, but when you see it this way, hopefully you can notice 2 is the y-intercept and 0 is the slope. So when we answer the questions down below, the slope is 0, the y-intercept is 2. Okay, so let's start at our y-intercept of 2. All right. And remember, if our slope is 0, you can really think of that as 0 over 1. We're going to be going up 0 over 1, up 0 over 1. Keep doing that, and you should start to see, okay, this is a horizontal line. What's happening is we're going to be graphing a line that goes through the y-axis and not the x-axis at all. So this is a horizontal line. Okay, and another way to understand what's happening here is you can even make a little table of values if you want to. This is a slightly different approach. And what's kind of strange is it doesn't really matter what you, quote, plug in for x. No matter what number you choose, 0 times anything is just going to be 0. No matter what numbers you plug in, you're always going to have a y coordinate of 2. So this might be a helpful reminder if you get stuck graphing on the homework or something. Just remind yourself, okay, it doesn't really matter what x is as long as the y coordinate is 2. 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, etc. going through the y-axis at 2. If we had the equation written with x instead, if it was, for example, x equals 5, that would be a different scenario where you'd be going through the x-axis as a vertical line. And in that case, the slope would be undefined. But still, you could use the same approach of making that little table of values, kind of going from there. Okay, so that's all we have here. That's our quick review of slope and linear equations. And I hope this helped. Let me know what questions you have. Thank you.